Right, today we're looking at factoring expressions of the form of ax squared plus bx plus c. That is, we're dealing with complex trinomials. Alright, let's start looking at some examples, and in fact, before we start looking at these examples, I want you to refer to this sheet which has a flowchart. It's a flowchart that will help us to factor expressions, right? So the first thing that we're going to do every time is we're going to look first for a greatest common factor among all the terms. After that, we will see, we have to decide whether it's a simple trinomial or a complex trinomial, right? And if it's a simple trinomial, we deal with these steps, and if it's a complex trinomial, we will deal with these steps, right? And the middle part, well, I'll have a video lesson for that later on, but I'm sure that by looking at the flowchart, you may be able to figure it out. Alright, let's start with our first example. Okay, so we have 3x squared plus 5x minus 2. Okay, is there a common factor among all of these three terms? No, not really. So, is it a simple trinomial or a complex trinomial? It's a complex trinomial. So if it's a complex trinomial, we know it's of this form, right? ax squared plus bx plus c, right? And we know, right? And we know that a is equal to 3, b is equal to 5, and c is equal to negative 2, right? So complex trinomial, factoring a complex trinomial, it's very similar to a simple trinomial. So in this case, we're going to factor this. So first, we're looking for two numbers that when multiplied will give us a times c. In this case, 3 times negative 2, right? So we're looking for two numbers that when we multiply them, we want to get a times c, and when we add these same numbers, we want to get b, right? So essentially, for this particular example we're dealing with, we're looking for two numbers that when multiplied will give us negative 6, right? 3 times 2 is negative 6, and when we add these same numbers, we want to get 5. Right? So what are these two numbers? What are these two numbers? Well, let's see. 3 and 2 will give us 6, right? If we want to get a negative product, we know that both numbers will have a different sign. So a positive 3 or negative 2, right? That might work, right? So we get negative 6, but when we add them, we don't get 5. So what are these two numbers? Well, I would say these two numbers would be positive 6 times negative 1, right? When we add those two, we can get a positive 5. Okay, so since we found those two numbers, what we do is the following. We use a technique called breaking up the middle term. So that means we take this expression over here and we do the following. We write 3x squared, and now we split this middle term into those two terms that will satisfy these expressions right here. So our two numbers are positive 6x, right? We're splitting up the middle term into positive 6x and negative 1x or negative x, right? Well, I'm going to put negative 1x this time, right? And then we bring the negative 2 down. So we split the middle term, right? We split the middle term because we know that when we add plus 6 minus x, we're going to get positive 5x, and when we multiply positive 6 times negative 1, we're going to get negative 6, which is what we're looking for. Alright, so once we break up the middle term, what we do is the following. We factor by grouping. So we consider these two terms, right? Let's group these two terms. Let's find what's common in them, and let's factor it out. And let's group these two terms, and let's find what's common in them and factor it out. So between these two terms, common factor would be, well, the 3 is a factor of both expressions, and the x, right? So let's open up the bracket here. So 3x times x will give us x squared, and then 3x times 2 will give us 6x, right? And between these two expressions, we can factor out, well, it's nice to leave this with that positive x coefficient in front. So let's factor out the negative one. Okay, I won't write the negative one now. Just negative open bracket and negative times x in order times positive x in order to get negative x, and negative times positive, negative 2 times 1, 2, right? So we have these two expressions now. Now let's keep on working our solution here, right? Now between these two expressions we have a common factor, and that turns out to be the binomial x plus 2. So let's factor out the x plus 2, right? X plus 2, and then we end up with 3x minus 1, right? So x plus 2 times 3x, it gives us this expression, and then x plus 2 times negative 1 will give us this expression, negative x plus 2 in brackets. All right? So we factored our complex trinomial here. All right. Let's look at one more example, which is slightly more difficult, not too bad. All right. We have 6s squared minus 29s plus 35. All right. So same idea, and I'll go a little faster on this one, but I also want to show you something that I believe will be very useful. Okay, so first we're looking for two numbers that multiplied. Well, let's step back a little bit. First, is there a common factor among all of these terms? No. Down the flowchart. Is it a simple trinomial or a complex trinomial? Complex trinomial. If it's a complex trinomial, we're going to use the technique of breaking up the middle term. But for that, we need to do the following first. Okay, so we're looking first for two numbers that will give us, that when multiplied will give us a times c. So what's 6 times 35? What is 6 times 35? Okay, so 6 times 35 is 210, right? Well, positive times positive, 6 times 35 is 210, right? And when we add these same numbers, we want to get negative 29, right? Okay, so what do we do here? We want to get positive 210 and negative 29. Okay, so how do we split up this this expression, right? Maybe a little bit, it's probably a little bit hard since we have a big number here. So what we can do is we can do the following. Okay, we know that the multiplication will be positive. We know that our number is going to be 210. Okay, so what we can do is we can start breaking up this product into its prime number. So for example, 21. 21 is the same as saying 21 times 210. 210 is the same as saying 21 times 10. Right? Let's keep on decomposing this number until we reach all the prime numbers. Right? So 21 times 21 is the same as saying 7 times 3. So that's it. These two are prime, and we're done with that. And over here, 5 times 2. Alright, so we managed to split up the middle, decompose this number, 210. Now, I recommend using this technique because this is what helps us to figure out what two numbers would satisfy these expressions. Sometimes it can be quite difficult to figure those things out. Okay, so let's look at this. What two numbers? So what we do is the following. We start collecting numbers, putting them together, and see which ones will provide us. Okay, so we try different combinations. So for example, 7 times 3, 21, and then 5 times 2 is 10. So if we add 21 plus 10, we get 31. That's not what we need, okay? We know that the product will be positive, so both numbers have to have the same sign here. So it's either both positive or both negative. So even if we added negative 21 minus 10, we still don't get negative 20. Let's try other combinations, right? How about 6 times 35? That might work, all right? that might work. However, when we multiply them, yes, we'll get 210, but when we add them, okay, so they both have to have the same sign, but at that point we really can't do anything. So let's try another combination, and I suggest the following, right? How about this one? 7 and 2, we join them together, so 7 times 2 gives us 14, and 5 times 3 gives us 15, right? So 7 times 2 we get 7 times 2 gives us 14, and 5 times 3 will give us 15, right? So now we can combine these two numbers, right? 14 and 15 to get -29. Right, this video is too long, so I better stop now.